Hello, everyone. I'm Ken Hanson. I'm an associate professor in the Department of Chemistry and Biochemistry at Florida State University, and I'm here today to talk to you about one of our recent papers we published called Using Classical Test Theory and Rasch Modeling to Improve General Chemistry Exams on a Per Instructor Basis. And here's the reference here. It's published in Journal of ChemEd in 2021, so you can look at that if you want additional details. But this paper is slightly different than most of our research papers. In this case, we're talking about the teaching aspect of what I do as a professor. And so just a general overview, we all know exams are important to teaching general chemistry, at least in our current paradigm, right? They're how we assign grades, they're how we determine performance metrics and all sorts of things. But most of our exam writing, barring having standardized tests or shared exams across classes, is very subjective, right? The teacher takes it and looks at questions and says, do I think these good or do I think these are not good? And so that bothered me. And so what I decided to do is we wanted to use statistics to figure out if we're giving good exams, if we're giving good questions, and understand how we can make our exams better. And so we basically did 3 iterations of a general chemistry class. And the idea was to analyze exam outcomes using classical and modern testing theory, using repeated questions or linking questions to compare between semesters, and then use design criteria to make these exams better and obviously track these metrics over time to see if it actually works. And so ultimately our goal is, again, to assess the quality of the exams and the questions and to improve the exams as we progress, as shown here in the TOC image. And so to do this, we use multiple choice exams. I won't get into the details here, but basically multiple choice exams are a better assessment option than open-ended question. That sounds counterintuitive, but if you look in the literature and look at the references in our paper, basically there's a general consensus. It's more reliable, it's more valid, it's more consistent, it's more objective. It has a lot of advantages. One of the biggest advantages being you get spreadsheets that look something like this, and you can do statistical analysis on them. So in our particular case, we did a collection of classical testing theory metrics like average, which is standard Cronbach alpha, which is a validity metric, discrimination index, and point biserial. They're basically comparing students' performance on a given question to the overall performance in the class, and it tells you something about the quality of the question in relation to the overall exam. We also get things like modern testing theory. And so the difference between classical and modern, one of the big ones is modern testing theory doesn't assume that every question is equally difficult. And so you can do something called Rasch analysis, or it's one parameter item response theory. Basically, you get student ability and question difficulty. And so you're effectively fitting it to a model, and you get things like outfit statistics. And so doing Rasch modeling, you get something like this. It's called a right plot. It basically shows a distribution of student abilities on this side, and then a distribution of question difficulties on this side. And so in this case, you can see, if I move my head, you can see the less difficult questions are down here, the more difficult questions down here, the lower ability students show up down here, the higher ability students show up here. And so we get student ability, we get question difficulty, and then we do all our statistics and we get a whole bunch of exam metrics. And so we can see a lot of problematic things in this analysis here. And so we see high item independence. It's basically one question relies on another. We see low Cronbach alpha values. And so here's the alpha. 0.6 is the bottom threshold where you would consider a test acceptable. In exam 3, we're near that. Exam 1, we're pretty close to that as well. You want that number to be above 0.7 or even above 0.8. We can also do the overall question metrics, how good a question is. So D in this case is difficulty. It's basically number percent of questions over 90% success, percent of questions below 30%. We have our discrimination index and point biserial, and we can see very good, fair, poor questions, what percentage of the test fell under those criteria, and outfit statistics as well. And so you can see our percent of very good questions is low. Our percent of fair and poor questions is really high in this first iteration between exam 1, 2, 3, and the final for our first time teaching this class. And so again, not a particularly good test as by the overall metrics as well as the per question metrics. And so what we wanted to do next is, can we improve this exam? And our first step towards that was doing a linking question to the next iteration of the exam. So we take fall 2017. Next time I taught this was spring 2019. I wanted to use linking questions. And these are basically questions we choose from the fall 17 exam that we're going to reuse exactly the same on spring of 19 exam. And so we're going to use this for a few different reasons, but one of the major ones is to do an equating procedure. And so the idea is if I had fall of 17, I took 3 exam questions here, item A, B, and C, and I reused those in spring of 19, items A, B, and C. I can basically use these as a metric to put both of these exams on the same scale. And so that's what the equating procedure is. And so through this, you can basically see, okay, if I taught this at a later time, this is an easier exam. This one is a harder exam, but I can put them both on the same scale because I know these linking questions can compare between the 2 exams. And so you can read more about this equating procedure. One thing I will note is this is arguably the most fair way to assign grades rather than average, because that's dependent on how difficult the exam is or on percentage of the class. In this case, you have an ability metric or a question difficulty metric that you can draw the same line across several different classes as long as you have equating items to compare them. All right, and so we can take and pick what our linking questions are based on all the metrics we talked about previously. I'm not going to go through these. You can read these in the paper. But basically, here's a bunch of metrics. We said, here's how we're going to prioritize our linking questions. And we can go through our questions from fall 2017 exam and pick out our linking questions. And then we can also introduce some design criteria for new questions. And so we have 10 linking questions, 30 new questions. We put those together. We have a 40 question new exam, and we want to see how good that exam is. And so here's the equating statistics. I won't get into those, but basically we have 10 linking questions. We can equate them on a graph, and basically the slope of this line tells us how to calibrate between the 2 exams. And so we can actually put 2 different exams on the same scale. And so fall of 2017 versus spring of 19, you can see the difficulty was higher in the spring of 2019. In the fall of 2017, it was an easier exam, but the students had higher ability in spring 2019 versus fall of 2017. And so although the exam average was lower in spring of 19, it should be because the question was more difficult, but overall the students had a higher ability in spring of 19 than they did in fall of 17. And so this is why comparing using linking questions is so important, because you can account for exam difficulty. And so again, we can compare our metrics between fall of 17 and spring of 19, and we can do things like percent independence goes down, Cronbach alpha goes up dramatically, percent of questions below student ability fell dramatically. We can also see question quality, how that compares between the 2. And so basically in nearly every single metric, our second iteration of this exam got better. 1, because we took 10 quality questions and we repeated them, and 2, because we used design criteria for the additional 30 questions. And so again, by nearly every metric, the tests got better. And so we can chart this over time, and we can do it for exam 1, 2, and 3 over 3 iterations of the class. So fall 17, spring 19, fall of 19. This is exam 1 column, exam 2, exam 3, the final. Just a couple metrics: Cronbach alpha, percent questions, discrimination index, and point by serial. And so we can see again, for overall exam metrics, the Cronbach alpha went up across the board. And so every single iteration on every single exam, our test got better. It was more reliable, more valid as we progressed. You can see down here the question quality: orange is good, blue is bad. You can see the amount of orange is going up, the amount of blue is going down. Again, across the board, the test is getting better. And so overall, this linking question strategy as well as question design strategy showed us statistically that our exams are getting better with every single iteration. And so we can continue this process and just keep pruning questions, pick good ones, design better ones, and we can just keep improving our exams. And so very promising approach that we look forward to continuing in the future. And so acknowledgments for this: Florida State University and the Department of Chemistry and Biochemistry for letting me do this. Also Gen Chem students for approving it. It's IRB approved, but they still have to give their approval that I can use their data, so I appreciate that. I'd also like to thank my colleague Benjamin Sorensen. He's a computer scientist / statistician who really knows this stuff well and did the statistical analysis and helped compile the data and write the paper, so I really appreciate that. I also like to thank my teaching assistants for every iteration of the class. They help design the question, choose the questions that'll be on the test, also proofread the test and make sure everything looks okay. And so fall of 17, spring of 19, fall of 19, I'd like to thank all these groups as well as all my TAs before and after that have helped with question and test design.